Yeah, so hello. My name is Piotr, as Pavel just introduced me, and I'll try to share with you my opinion that may be controversial one, that infrastructure as code is not alchemy. And I will try to share with you an amusing story of our road to Terraform through different infrastructure as code tooling. But first, who am I to even speak about those things? I started my IT journey in 2018, right after I graduated my studies, and I studied biotechnology, so this is not something really related to IT. I started as a support engineer. I worked night shifts for a year, learning Linux during those night shifts. After a year, I became a Linux system operator specialist, which was my dream come true back then. After 2 years of learning a lot about operational side of things in IT, I moved to a DevOps role to build and manage cloud environments, which was really cool, and I still think that this is the coolest thing ever. And last year, as Pavel said, I got hired by Ocado as a cloud engineer, and I have never been happier before. Yeah, and during my adventure, I gathered few certificates that proved to be useful, at least some of them. Yeah, but I would like to know you a little bit better. I don't know who I'm talking to. I'm from Wrocław, by the way. And show of hands, who of you are currently working in IT in some operational role, like system administrator, DevOps, something like that, cloud engineers? How many of you? Right. That's nice. And how many of you are working with cloud environments, any cloud provider? That's really nice. So you will be very familiar with what I'm going to say. You will probably know most of it. But how many of you are software developers or working with programmers, coders, or something like that? Great. Good to see so many open-minded people. There are some tools for you as well. And after this talk, perhaps your stacks will be the fullest in the company. Who knows? And how many of you are not currently working in IT, and I'm looking for switching to IT to get an IT role? Nobody. Everyone is working here at you, right? There is one person. All right. I would like to inspire you to see that IT is not just programming. It's useful, of course, but there are other fascinating fields in this field. Let me put it that way. All right, moving on. I will start with describing shortly, very briefly, what even is infrastructure as code, but I see that most of you probably already know it. And we'll go with our with our adventure, how our initial infrastructure in the cloud looked like, how we started to manage it with CloudFormation. Then we'll move to the phase when we started signing more and more clients, and we had to introduce a new runtime. How we try to manage it with Ansible, which is a weird choice, I know. And we'll move towards current years, how we started to struggle with CloudFormation and its shortcomings, and why we switched to Terraform, how we switched to Terraform, at least in some way. And why you should consider switching to Terraform, and why perhaps you should not. We will see. All right, but most of you already were working with some cloud providers. You know that you can create your resources by clicking in the AWS console, for example. You can type your name of, this is the example of typing, of creating a virtual machine in AWS. You have to type manually the name of the virtual machine, pick the size, etc., etc. This is cool if you want to test a new functionality, new service, or something like that. But if you have to manage a large infrastructure, it can be tedious, very error-prone, and there are better ways to declare your infrastructure. For example, with use of infrastructure as code methodology and tooling, which allows you to declare your infrastructure once in code, in some configurational language, and then just deploy it with a click of a button. So let's start with our history. It didn't start in 2016 because Ocado is on the market for 20 years, 25 years, something like that. But in 2016, our repository starts. None of my, at least the repository that manages our infrastructural code, none of my teammates, or my current teammates, work here. So this part is all my forensic work in this repository. Apparently, we had very few clients, and by clients I mean retailers that hosted their web shops on our platform. We had very few AWS accounts to manage, so the infrastructure wasn't that large. It was a space for learning, for improvisation, because most of the cloud engineers back then were converted from being system administrators, because we were moving from on-premises infrastructure towards AWS. And the infrastructure was pretty simple. There was a single ingress for a given domain for our customer. There was, of course, DNS. It was either hosted in Route 53, which is an AWS service for DNSs, or some of the DNSs were hosted on premises. All the requests from customers were forwarded to our CDN service, which is for AWS, it's CloudFront with some security attached web application firewall. And then it was forwarded to Elastic Load Balancer. This is a classical load balancer, so you AWS nerds know how deprecated that is currently. Of course, the requests were posted to autoscaling group, then to our Nginx layer of Nginx is a web server. Funny thing is that those Nginxs were hosted on virtual machines and were running as a Linux service. And there was no way of, at least it wasn't implemented back then, to reload the configuration. So any changes in Nginx configuration resulted in complete destruction and recreation of all instances. So it took some time to recreate that. And then the traffic was forwarded to our runtime, which back then was Beanstalk. If you know if you don't know what a Beanstalk is, don't bother, don't use that service. It's not worth it for a serious runtime. As a serious runtime, there are better options offered by AWS. And of course, there was a S3 bucket that hosted the configuration for Nginx proxy. Pretty simple. Of course, we had to manage a few subdomains for a main domain of our of the retailer. Those has to be configured both on the DNS layer and on the Nginx. Each subdomain forwarded to a different application running on the runtime, and this is a challenging task to manage it. But it was a challenging task back then, and it's still to this day. This is one of the main, more commonly asked requested tasks that we have to do for our customers. As I said, we had very few accounts, and each account had very few of such main domains and routes. So the infrastructure was pretty manageable. And our first peak of infrastructure as code tooling landed on AWS CloudFormation. How many of you used CloudFormation? Anyone? Pure CloudFormation, no CDK, no nothing like that. Pure CloudFormation. How many of you liked it? Let the record show nobody raised their hand. Yeah, but why we picked CloudFormation? Back then, it was a mature solution. It was already on the market for 5 years. Whole company moved to a cloud-native approach from on-premises. We strive to use as many managed services as possible, because managed service mean that we don't have to manage it ourselves, and we can focus on something better. CloudFormation templates are configured in JSON or YAML, and I'll show an example in a second. It allows for rollbacks if an update of an infrastructure fails, although it doesn't work every time. It also has limited possibility of importing existing resources. So if you click something in the console and create it, for example, virtual machine, you can then later manage it via CloudFormation. It has some drift detection, although it's limited for only certain services in AWS. Upload is deployment is pretty simple. First, you have to create those templates, generate them, and if they are large enough, you have to first upload them to S3, from which the CloudFormation template, CloudFormation service can read them, and you can start the deployment from the AWS console or via API. Yeah, this is how our initially our repository looked like. We had our repository has been organized into domains. Each domain had one single large CloudFormation template, and had some environment-specific parameters. There were usually only 2 environments per domain, one for production use, and one for development. And of course, each, as I said, each domain had a large stack, very static thing. I will show as snippet. This I don't expect you to see anything. Just notice that it has 40 lines of code. Yeah, and we will zoom into just the properties to showcase some capabilities. You can, in CloudFormation, you can either provide a static value, a hard-coded value, like for example for cooldown it's 300 seconds, or you can reference a parameter with a built-in function. First you have to declare a given parameter at the very beginning of the template, and CloudFormation has some, back then it was cool features to restrict those allowed values to not over-provision some of your infrastructure. It allows you to set some default values if you don't provide it during the deployment. Yeah, and all parameters for given environment were kept in JSON files, both of them. Yeah, and also there was a site config catalog directory, which kept all, and I mean all, Nginx configuration files for each domain. They were all static, painfully static. There was no dynamical creation of configuration back then. And now we have both parameters. We have our template, and we have to deploy them. How? We created our own script, of course. There was upload.py and deploy.py scripts in Python. Both had together 100 lines of code, and they generally had a very simple mode of action. They read the files, the JSON files with parameters. They uploaded all the static files to S3, and then launched the deployment via API of AWS. It worked pretty well. It suited our needs, at least back then when the infrastructure was pretty small. Years passed, and in 2020, Ocado started experiencing new challenges. We already had, I maybe forgot to mention, back then we had like 4 AWS accounts to manage, and in 2020 it was already more than 20 accounts. We signed more and more customers. We had to prepare more and more platforms. We already had multiple cloud teams operating, managing all different parts of the cloud environment. New runtime has been introduced that had to replace Elastic Beanstalk, and ECS has been picked. And this is where my current team comes in, because my team has been back then established. With the first task was to figure out how to manage this infrastructure in a better way. Yeah, we choose to still use the CloudFormation. We had to somehow, because this was the company standard back then, but we didn't want to create our own scripts, although there was an idea to create something, but in Java this time, like this would help. No, it wouldn't. So we decided to check the market and start using some tool, the existing tool that we don't have to manage and don't have to upgrade on our own. And one of the senior engineers proposed Ansible. Why Ansible? Everyone had some general familiarity with it. How many of you used Ansible for anything? Yeah, and I believe most of you already were some system administrators or something like that, right? No? Okay, yeah, but most of us were at some point of our career system administrators, and we all were familiar with Ansible and playbooks. It has simple syntax. It uses YAML, which is pretty readable syntax. It's pretty readable. It allows for code reusability, which was painfully absent with the static CloudFormation template. Ansible has something like roles, which are like modules or classes in programming languages that allow to call the same piece of code over and over with different parameters, with different variables. It also supports Jinja templating, which adds additionally a layer of the dynamicality to static CloudFormation templates. And it had a module that supported almost natively provisioning of basic AWS services. We were mostly happy with just CloudFormation and S3 and some Lambda. We didn't require all of those because every single other resource has been launched via CloudFormation. Yeah, and we found our hero. It worked. This is how our runtime looked like. Back then, we only had one single ECS cluster. All runtimes grew to 3 clusters because more clients had more requirements, and we had to deploy different clusters with different capabilities. For each cluster, we had to deploy, of course, a test service for monitoring purposes and few Lambda functions to add some functionality that is lacking in ECS. Yeah, workarounds. We decided to organize our code differently. This time, it has been organized per account. Each retailer now stored or hosted a whole environment on different accounts. So that was an improvement. In the inventories, in inventories only stored parameters specific to a given environment and given retailer. At the bottom, there were roles, which were, as I said, the reusable parts of code. In the role, for example, for each role, there was a Jinja templated CloudFormation template down here. We'll take a look at that in a second. And of course, playbooks were running the roles with a proper set of parameters to deploy it. It was pretty self-explanatory. Yeah, this is a snippet of CloudFormation template with Jinja template on top of it. It allowed for some cool functionality like injection of Ansible facts into the CloudFormation template. These are not parameters declared in CloudFormation, but are taken from Ansible facts. And also it allows some dynamic functionality like conditional statements and for loops, which was pretty cool. CloudFormation didn't support it until this year, but I will mention that later. And this is a snippet of our playbook that deployed everything. There are 3 main tasks. First, generate the CloudFormation template with the parameters. Second, upload it to a S3 bucket. And the third one deploys it to CloudFormation. This is only less than 30 lines of code and already does the same amount of work like the 100 lines of code scripts in Python, right? So this was an improvement, at least back then. Yeah, but 2 years passed and we still had some issues. We started to notice that we have to deal with more and more shortcomings of CloudFormation, and there were a few of those. Yeah, so the most important one, at least in my opinion, is that CloudFormation doesn't really support, has no easy way to reference an existing resource in AWS that is not managed by the same CloudFormation stack. It has some possibility to do so, like for example with named export, but you have to know that the other resource that you want to reference is deployed via some CloudFormation stack, and you have to ask politely the owner of this resource, of this CloudFormation stack, to add the export. Same goes with SSM parameter. CloudFormation has built-in functionality to look up parameters in SSM parameter store. However, the owner of the other CloudFormation stack has to export this the thing you want to reference in the SSM parameter store, which can take a while, right? You can try to guess the ID of the resource by doing some substitutions in the string. Or you can use built-in functionality of macros, which basically run Lambda code, your Lambda code, during the deployment of CloudFormation template, and this Lambda code can look up the value you want to look up, and then inject it into the CloudFormation template during the deployment. If this is not a workaround, I don't know what is. And they built it in, right? Yeah, the other thing is that you can't really update a stack if one of the resources has gone missing. If somebody or something has deleted it, you have to recreate it with the same values or at least the same name. This is rather painful. And also, CloudFormation has been created in such a way that if anything is managed by CloudFormation, you shouldn't really, you are not supposed to change anything or adjust the resource in any way outside of CloudFormation, because stacks won't update without you aligning the infrastructure with the state. Yeah, there's also a thing of lacking features. Drift detection is quite bad. It's only supported by a limited number of services. And it's supported only for AWS services, and even though it's limited to only a few of them, deployments are pretty slow due to some obscure timeouts. Sometimes you deploy something and there is an obscure error during the deployment. The deployment won't fail because it will wait for the resource to be created, but the timeout is usually set for something like 2 or 3 hours, so you have to wait until it times out, until you will be able to do something with the CloudFormation template. There is a limited number of resources, existing AWS resources, that can be imported and managed by CloudFormation template, CloudFormation. Although the number of resources and services is pretty impressive, there are still some that are not, after 12 years of being on the market, which is weird. This is an AWS service after all. Adding anything outside of AWS is really painful. We decided to use a third-party autoscaler for our ECS clusters, and we had to write about 200 or 300 lines of additional CloudFormation code that has never ever been changed afterwards in order not to break anything. We are just praying every time we deploy it. Yeah, and weirdly enough, or not, considering that CloudFormation is a proprietary service, it's not open source, any support for new services comes pretty late, at least compared to open source solutions. For example, last year, the AWS introduced serverless OpenSearch, and it has been possible to manage it via CloudFormation after a few weeks. Because we had to wait for the internal teams to finish their sprints and etc. And for example, in AWS in Terraform provider for AWS, the pull request has been opened within a week to implement this functionality. Nice. And generally, new features are very rarely introduced. We had a laugh when they introduced for loops in August of this year, after 12 years on the market. Every single other infrastructure IaC tool already has for loops built in from the very beginning, and it took them 12 years to implement those, right? Yeah, and of course we have to take into consideration that we used Ansible, which is not perfect from the beginning. Deployments were pretty slow. Yeah, the CloudFormation has to be first generated. It has to be uploaded, and then it can be the deployment can start, which takes a while. Additionally, Ansible works sequentially. It has to process each stack in a sequential manner, which also takes a lot of time if we have a lot of tasks. And there are so many parameters we are very often losing ourselves, because we have to. It's hard to remember what is an Ansible parameter, what is an Ansible fact, what is a CloudFormation parameter. It's easy to lose track of things. And we have to we can't forget that we still had the repository of proxy that deployed the proxy layer that still used custom scripts after 6 years, yeah, or so. So somehow this script has to grow to 500 lines of code of custom script that we have to manage. And somehow, some way, it now has a brother, deploy v2, a little brother. And the best part is that both of those has to be executed in the same job for the whole infrastructure to be deployed. Each of them had some functionality that other lacked. And I don't know who decided to create a second script instead of build the first one anew or something like that. Yeah, we still signed new retailers. We still had to create and manage new infrastructure on new accounts. And there were so many subdomains. And until then, we were trying to mix one faulty thing like CloudFormation, at least in our opinion, with another faulty thing like the deployment tool, like either custom script or something like that. And we expected something good to happen, and it never did. So we were doing some alchemy, and as I said, that's my opinion, infrastructure as code is not an alchemy. Our proxy layer increased. Now we have 3 ingress layers. I will just point out that we are now using application load balancers. There's one way that uses API gateway and network load balancer. And we moved to OpenResty, which is a distribution of Nginx that allows to implement some custom Lua code on top of Nginx, which is pretty neat. And we started running our proxy on containers running on EC2 instances. So it was much quicker to reload configuration. But each of those ingresses had 3 main domains. All of them had to have some subdomains to be configured. All of them had to be configured on DNS and OpenResty, and there was so many of those. This is for one. This is an infrastructure for one account, right? We had 100 of those back then at that point in 2022. So we needed a hero. We needed a change. That's why we decided to move to Terraform. How many of you use Terraform? Okay, and how many of you have good experience with Terraform? I mean, they like it. Okay, and how many of you don't like Terraform or have some negative? Good, that's a good answer. For the record, nobody raised their hand. I expected it, Yeah, but Terraform is cool. It's completely open. Oh, no, I cannot say that. It's not open source anymore. But it has providers which are usually open source. Providers are plugins which add additional functionality. They kind of work like modules in Ansible, but they're much better. They have a killer feature called data sources, which I will show in a second, that can reference any existing resource supported by a provider, and you don't have to own this resource. This is pretty neat, and it's really real lifesaver. Deployments are much faster and simpler because you don't have to upload anything, you don't have to generate anything. You run everything from CLI or from your CI pipelines, and Terraform deploys everything asynchronously. You don't have to wait for the task, each task to be finished before you start with the next one. Of course, it has some. There are some dependency between resources. In my opinion, it has superior drift management, at least in opposite to CloudFormation, because it supports drift management for every resource that given provider supports. It's not limited only to those that AWS supports. You can use versioned Terraform modules. You can also version Ansible roles, but this requires much more of a hassle. It has a wide market adoption. There are a lot of tools available to support it. It has a powerful CLI. You can, just from CLI, you can format your code. You can validate it that is correct. You can graph any dependencies between resources. You can manage state. You can it even has a console which works as a REPL. You can test your Terraform logic. It's configured in HCL, which is a HashiCorp configuration language. It's a proprietary language. It's a minimalistic language. It has all the dynamic features you need, but doesn't have those that would complicate things like classes and stuff. Some people love it, some people hate it. So from our initial organization of code per domains, we moved to organizing our code the same as we organize it in the ECS repository, per retailer and their accounts. Each retailer had few environments, and each environment had some simple Terraform files that usually just local store, local configuration and parameters, and other just called the modules and created some additional resources if they are required. You may also be wondering, what are those? Those are not regular Terraform files. Account params, all the HCL files and account params and Terraground HCL are used by a tool, a wrapper around Terraform that we use called Terraground. It's pretty neat. I will describe it in a second. But in account params, we could define variables specific for a whole account, so we didn't have to do it in locals. And Terraground HCL added some additional functionality. We could execute some Terraform code before the main execution of the main deployment. We could also execute some validation afterwards, after the deployment. It's pretty neat. And each environment consists of pretty much the same Terraground HCL file. We just had to point to separate to the global HCL file, and on the level of Terraground HCL file, the deployment occurs. This is where the Terraform deploy is being executed. This is an example of calling of the module. I won't show you the example of the module because it's a lot of code, but at least for the proxy, we created our own module. And let's first focus on the lower part, or maybe not. There's too far. This is an example of how cool the data sources are. If we want to deploy our proxy layer with the latest Amazon Linux 2003 version, we can just look it up on Amazon, on AWS, in their repository, by just calling the given data source with filters that are applying to us. We are using the most recent, and it always will return the ID of the most recent operating system version, and the ID of the most recent operating version. With other solutions, we had to do some workarounds. We have to look it up with some script. We have to run a Lambda or something like that. Now it's possible. We're just looking it up with Terraform. We don't have to write anything else. And next, this is a cool feature that really helped us a lot with managing those pesky subdomains. The subdomains are created, we call the module with the subdomains argument that points to a local file that stores the local variables, and this contains a map of subdomains, which consists of a name of the subdomain and the URL of the internal URL of the application to which this given subdomain had to be created. If we deploy it in the module, it automatically creates both the DNS entry for this subdomain and the Nginx configuration, dynamic one this time, all with use of Terraform and built-in providers and their functionality. And it will create dynamic configuration, so we don't have to keep everything, repeat the same lines of codes over and over again, which is pretty neat. Of course, if you consider Terraform, you have to keep in mind a few things. First of all, it's a self-managed service. It's not managed by AWS. State is kept by default on your local machine or in the place where you deploy, and it's stored as a plain text file. So if you have any secrets, they can be read. So it's better to use some additional infrastructure to store it, like encrypted buckets or DynamoDB tables. Using Terraform at scale can be tricky. Also, using Terraform in multi-region scenarios can be challenging because each provider works on single domain, on single region basis, and that's where TerraGrant comes to help. It can generate, for example, you can configure it in that way, so it generates providers for the specific region you need at the during the deployment, at the time of the deployment. So it is generated just in time. And of course, static code analysis. Although both of those solutions work for CloudFormation, for example, Snyk is a service that analyzes code for security holes and vulnerabilities. And we tested it with CloudFormation, but with CloudFormation, the whole process of generation of CloudFormation template and Snyk analyzing a large CloudFormation template took 20 minutes per template. For Terraform, it took 3 minutes for our whole infrastructure. So there is that. We noticed a lot of other benefits. Deployment speed, development speed first has increased a lot. There's less code to manage, so it's easier to navigate and easier to create new things. Less workarounds because there are providers for almost everything, and everything is supported from the Terraform, at least everything that has an API. I checked that there is a provider for some pizza vendors, so you can order a pizza with Terraform if you like. There's less cognitive load because you have one set of parameters. You don't have to follow anything or connect anything. And there's also a better tooling for Terraform, as I said, TerraGrant, as I mentioned TerraGrant before. Deployment speed increased from about 10 minutes with our transformation template solution to less than 2 minutes, and that's only because we don't use caching that much. If we use caches for modules and stuff, it will be even quicker. There are fewer dependencies, of course, to be downloaded. Terraform is written in Go, in Golang, so it's a single executive file, binary file. You don't have to, if you download Ansible, for example, with use of pip, Python manager, there is like 12 or maybe even more dependencies that has to be downloaded as well. So that's pretty neat. And of course, the asynchronous execution speeds everything up. And I would argue it's easier to be hired and to hire a Terraform specialist, and I will argue that later. But you have to consider if Terraform is for you. There are many things to be considered. First, HCL. This is a proprietary language not used by anywhere else. It's used only for HashiCorp tooling. So you can use it also in Vault or what was that, Nomad. It's also pretty, can be discouraging. I don't know if you see it. But this is a conditional statement, and it doesn't use any if or else keywords. So you have to guess on which side is a true statement and or which is false, and I never know it. I always have to look it up. Yeah, providers, as I said, are written in Go. You can write one yourself, but you have to do it in Golang because HashiCorp provides SDK for writing providers only for Golang, which is a pretty neat language, by the way, but it's a new language that you have to learn usually. You have to consider additional infrastructure, like, for example, as I said, buckets for states. You can also host your providers and modules in Nexus repository, on sometimes, as far as I remember, also in Harbor. Or you can use Terraform Enterprise, which is a HashiCorp paid solution. They offer you to host your states, your modules, and your providers on their cloud, of course, for some payment. And there was a recent controversy of changing the licensing from fully open source to source available, which means that you can view the code, you can contribute to the code, but as far as I understand that, you cannot distribute the code if you take any payment for that, if you get any money for that. They have to have a share or something like that. And I didn't mention it, but there are no automated rollbacks. They don't work really well in CloudFormation, so I don't know if we miss anything. And of course, if some of any of those is a deal breaker for you, like for example HTML, or you are developers, some of you at least are, and you would like to use JavaScript for your front end, use JavaScript for your back end, and use JavaScript for your infrastructure management. There are possibilities. There are two, at least the most popular ones. There's CDK and Pulumi. Both are fully open source, like the best part of best kind of open source. One is a software framework, and one is software development kit. If you don't know the difference, stick with Terraform. Trust me, this is not for you. Cloud Development Kit CDK, it's an Ansible solution released in 2018, so it's pretty young. It uses CloudFormation as a backend. You can declare your infrastructure in your favorite language as long as it's what was that? Python, JavaScript, TypeScript, C# and Go, and Java. Of course, Java is everywhere. But overall, what the deployment does is it generates the CloudFormation template. It uses the CloudFormation template service, CloudFormation as a service. So you have all the shortcomings that I described previously. And Pulumi, you declare your infrastructure in a programming language, but it uses Terraform providers and a little bit more than that. It has pretty neat CLI. It uses by default, it stores by default the state in their cloud, so you have to configure it manually to host it locally. Since it uses Terraform providers and everything and supports almost everything that Terraform does, why not CDK for Terraform instead? Terraform also has a CDK, which is a software framework with which you can generate Terraform code or do Terraform deployments with use of the same languages, of the same programming languages. And what about those hiring issues? What I mean by that is that if you are a Pulumi expert at one company, or for example CDK expert at one company, and your current company uses Python, for example, for deployment of your infrastructure, and you are getting hired to a different company as a CDK or Pulumi expert, you are Pulumi expert, but they are declaring their infrastructure in TypeScript. This comes with a different set of tooling, different set of frameworks, and different set of all the things that you have to now learn. And if you are a Terraform expert in one company, you use HCL. This is a configuration language, but it's the same in every single company that will use Terraform. At least that's my view. That's why I'm not really interested in those, and that's why I'm such a fan of Terraform. You can argue with me about that if the pizza comes in with some beer in hand. Please don't judge and don't be very angry about those statements. And thank you very much for attending this talk. Hopefully you learned something, or at least you had a laugh. Do you have any questions?
I have a question.
Yeah.
Yeah. So thank you. Very interesting presentation. So I have a question about TerraGrant. So in case of recent changes, the licensing changes, it means that you need to use OpenTofu instead in future, or TerraGrant is okay, and how it works?
The licensing changes are only for the Terraform, and only if you use it. As an example, I will provide you with what was that? There was this platform, the competitive platform for HashiCorp Terraform. Sorry? No. This is not a competition. There was this. I don't remember the company that sold Terraform and whole process of deploying infrastructure with use, and the Terraform was the main part of it, and they sold it and didn't give any money to HashiCorp. They didn't like it. This is what open source license allows for, and they didn't like to share. I don't know if it's great. It is controversial, but you can use Terraform for anything you like as long as you don't sell Terraform. If you do it for creation of your of your platform or something like that, it doesn't matter. Terragrant is a different tool that is completely open source and doesn't really rely on license of Terraform. And there is OpenTofu. You are right. There's an immediately after the licensing change, they created a fully open source alternative to Terraform. And if you want to create a platform and sell, not create a platform, but or create a platform that creates other platforms and it uses Terraform in the core, then use OpenTofu because they will eat you alive. Any more questions? Yeah, I love it. Yeah, that's what I didn't mention. You're right. CloudFormation has the worst documentation ever. It doesn't show properly that everything is parallel. Every single parameter is parallel to one another. You don't know the dependencies between one another. And Terraform has great documentation. It's really the best documentation I ever read. Any more questions? Oh.
Let's get one more question, or else we might not be able to eat pizza on time. So
I wanted to ask if you created the whole infrastructure from the scratch when you changed to Terraform, or you were recreating some of the elements, and if yes, did you face any issues with this recreation? I mean, like, you know, there are some problems when you would like to fetch for already existing infrastructure and recreate it with Terraform?
Yeah, that's a great question. We didn't create anything from the scratch. We imported everything to Terraform from CloudFormation, which took a while. But Terraform has a better support for importing resources than CloudFormation, at least for AWS, in my opinion, I should add. We had to first, but importing resources can be tedious. You have to import them one by one. You cannot just import whole infrastructure that is deployed by a single module. And you have to gather all the required IDs of given resources. And you have to, of course, make them not dependent on CloudFormation. You can do it in both of those solutions. But it was a process. We didn't create anything new. We had to import everything and just manage it from Terraform. There are cool guides how to do it on the internet, at least for the imports. So that yeah, we had one greatly skilled engineer, which did it. He did it within 2 months, but he has some the team from Krakow which helped, and I don't know how long they were working on it. So it took a while because we have a lot of accounts to do it, but they were doing it sequentially, and they had to create an automated way to do it with some Python scripting and stuff to gather those IDs and required stuff. And I should mention that we are looking for someone. If you are interested in Terraform, in infrastructure, in writing self-services in Python, that's also who are you looking for. Feel free to apply. We are really looking for you. This is a fully remote job, so you can work from anywhere you want, at least as long as it's in Poland, of course. Yeah. Thank you very much again.